Now, one of the next questions on the document is, what's the average distance from the middle? Let's go back to the dominoes. Okay, what's the average distance of these dominoes from the middle? Well, this domino is in the middle. We have two dominoes here that are 1 unit from the middle. We have another domino that's 1, 2, 3 units from the middle, and another one that's 3, 4, 5 units from the middle. One that's, again, in the middle. One that's 2 units from the middle, one that's 3 units from the middle, and one that's 5 units from the middle. And we can designate that on the picture. Okay, we have our middle, which is 10. We've got an arrow 2 units from the middle for this number, which is our 12. 3 units to this one, 5 units to this one. 1 unit to each of these, not drawing 2 arrows, 1 unit to indicate that we're going to count that one twice. We might or might not decide to use 2 arrows to do that, because we can see by the height of the bar on the histogram that we have 2 of them. There are 3 of them, 3 units here, 5 units here. Okay, same numbers that we got when we looked here, maybe in different order. And the order doesn't matter. So what are the distances from the middle? We have distance of 5, 3, 1, 1. That's starting from the left, 5, then 3, then a couple of 1s. Then 0, we want to include that. We don't really need to include the 0 if we want to get the right total. But later, if we look back at our calculation and we don't have the 0 there, we might accidentally count only 7 numbers up here, and we might end up dividing by 7 instead of 8. So it's good. It's a good idea to have the 0 in there. Even though we know right now that there are 8 numbers in the distribution, the calculation isn't going to look quite right unless we include that 0 there. Okay, so anyhow, we list those distances, and then we add them up. We get 20. So the average distance from the middle is what? 20 divided by 8, which is 2.5. Okay, I'm also going to mention, I asked everybody to look at a certain video that kind of made a transition from the probability chapter to this chapter. Here's a distribution, and I asked people to speculate on what that distribution might represent in terms of rolling dice. So you ought to think about that. And you ought to pause and think about it for a minute, see if you can see what that tells you. Well, I'm going to go on and hopefully pause and thought about it if you don't already know. What you can get if you roll 2 dice is going to be 2 through 12. There's 1 way to get 2, 2 ways to get 3, 3 ways to get 4, 4 ways to get 5, 5 ways to get 6, and 7 ways to get 7. And then that decreases back down in the same way. 5 ways to get 8, etc. Just a little bit of terminology. These distances here are deviations. So that what we have here is the mean deviation. And that's kind of an important bit of terminology. If we understand the mean deviation, that's a good basis for understanding the standard deviation, which is calculated in a slightly more complicated way. You don't need to know this or remember it, but if you want to, it won't hurt. What you do to get the standard deviation is you square all of these, you add them up, you find the average of the squared deviations, and then you take the square root. That's your standard deviation. But that's a subject that we'll go into in more detail in another class. Now, why would that mean deviation be important? Or actually, the standard deviation is even more important for reasons that we won't completely understand because they go a little bit deeper into more advanced mathematics, but we'll ask you to accept that when we get to it. Well, what would happen if I moved all of these dominoes except the ones on the end further from the middle? Okay, what would happen to our mean deviation? Well, what would happen to our mean deviation is we move all but these 2 further from the middle, the mean deviation is going to increase because these deviations are going to increase. We're going to get bigger numbers for all but the 5 and the 5 here. Or we could move all of them closer, maybe leaving the last 2 the same, or maybe we just move all of them closer, so that the distribution is more bunched up, and that's going to give us a smaller mean deviation. So a mean deviation is a measure of how spread out the distribution is. Now I'm going to write this down, but the board's a little wobbly over there, and it's actually kind of upset the balance already. So I'm going to pause here for a minute and get rid of the meter stick. Okay, I didn't really lie, but I changed my mind, and I kept the meter stick here for just a minute, just to illustrate. Here's a situation where the dominoes are spread out more. That would correspond to actually different numbers here, and that would correspond to a greater mean deviation, and it would also correspond to a greater standard deviation. The dominoes are on the average more spread out, even though the end dominoes are in the same place. And now here's another distribution with the same mean, but the dominoes on the average are much closer to the center, so the mean deviation is going to be less. It wouldn't be a bad exercise for you to estimate where these are and calculate a mean deviation, but don't regard that as a requirement. Also, I'll notice that in this distribution, this distance here, I can span pretty much with my hand from the mean to the leftmost. Over here, well, hopefully you saw it before it collapsed, but this domino was much further from the middle than this domino was. And I'm not going to bother setting those up. What just happened is what I've been worried about throughout this whole series of videos. So the mean deviation is, I'm going to say, one measure of the spread of the distribution. How much is the distribution spread out? Another measure of the spread could be the distances to the extremes. Okay, on the distribution that we had here, the difference between the extremes was 10, and that's called the range of the distribution. Within the range, we can still spread the numbers in the middle more or less, as we just saw, and get obviously different results for the mean deviation. And I'll also mention, because I mentioned the word, the standard deviation is what we get when we take the square root of the mean of the squared deviations. Again, square the deviations, add them up, divide by, in this case, 8. That gives us the mean of the squared deviations. Okay, mean of the squared deviations. Then we take the square root of that. And that, again, that comes up very shortly in the course, but it won't hurt you to kind of think about it right now in relation to what we've seen here.